Hi, today I will talk about the car price prediction based on machine learning. So the research question is, can machine learning predict the price of a car? But why do people care about these things? It has the 5 reasons. Predicting car price helps set bargain range for informed decisions. Predicting car price assigns financial institutions with investment management, loan amount and interest rates. Manufacturers and dealers can optimize pricing and market strategies using price predictions. Predicting car price helps the regulatory agents monitor market price and prevent unfair pricing. Insurance companies use the price predictions to evaluate car values and determine fair premium. Now, I will introduce the dataset. I get the dataset from Kaggle. It gathers the different types of cars from the American market. It covers 205 car models. Each unique is attribute, no non-value, no duplicated value. And I read the datasets. In the study, I found some are numerical and some are categorical. Therefore, I categorized them into numerical features and categorical features. The data also needs pre-processing since the categorical features have different type of value. I mapped each value to a unique integers. To ensure the performance of machine learning models, I calculate the ratio of power to weight. Create a new features for each numerical feature where the value is the square of the original feature's value. Apply a log transformation to ng-size to scale it to a more suitable range. And the last, use the standard scaler to scale the features to a distribution with a mean of 0 and 1, a standard deviation of 1. About machine learning models, I choose the regression models because this model is ideal for predicting the continuous numerical variables like the car price, can prove the occurrence predictions. This model is also easy to calculate, quickly to train, and suitable for this data size, completed the training and the predictions in a reasonable time. And this model is also the performance will in the practice, accurately predicting numerical variables. Splitting the data size. The efficient x and y. X contain all the features except the price and the car name. Y is the price. And then I divided the dataset into a training set and the test set, 80% for training and 20% for testing. And the last, set the random seeds to ensure that the results are the same every time the data is divided, so that the result can be reproduced. About the training, use the training set to train the linear regression models and the decision tree regression model. The predictions. The trained model is used to predict the test set and generate the target values for the prediction. The last is the evaluates the module. I use the 2 measures. The first is the mean square error. The smaller the value, the smaller the prediction error of the module. Coefficient of the determination. The value of the square of the R is between 0 and 1, and the closer it is to the 1, the better the model interprets the data. This is the result, the linear regressions and the decision tree regressions. In the result, I found that the decision trees models outperform the linear regression models in prediction performance. Then, it is about concluding comments. The first is the data preprocessing. Clean data to improve the model occurrence. Standardization and normalization speed up the model trainings. Data cleanings may lose the useful information. Complex pre-processing increase computational cost. Balance complexities and the computational resource when handling complex data. Cannot fully resolve all data issues, especially bias and the noise. About feature engineers, improve the model performance and reduce the computational cost. Capture complex data patterns, may lead to information loss. Increase the processing complexity. Balance quantitative and qualitative of the feature to avoid overfitting and computational boundaries. Features may still not capture all data complexities. About the model selection, linear regression is simple and effective for linear relationships. Decision trees handles complex non-linear relationships. Linear regression performs poorly with the non-linear data. Decision trees are prone to overfitting and noise sensitive. Balance model complexity and predictive ability to avoid overfitting or underfitting. A single model may not fit all needs, potentially requiring multiple models. The last is the model evolution. Cross validations provide the robust performance evolution. Multiple metrics give a comprehensive understanding of model performance. Increases computational cost. Different metrics may yield varying results. Balance comprehensiveness and computational resource. Choosing appropriate methods to reflect model performance accurately. Metrics may not fully cover the real-world performance, requiring practical judgment. The last, I think the project have some limitations. The first part is the limitation of the data. I think it have the 4 limitations. It's just only 205 rows is easy to overfitting. And about features, missing the important features like the market trend and the brand reputations. And may lost semantic meanings in the categoric characteristic. And the last is the simple bias. And even the representation of the brand or models affect the occurrence. Another part is about the machine learning models. Linear regression is necessary to assume a linear relationship between the features and the target variable, and it may not be possible to capture the non-linear features. The feature scaling is required to increase the complexity of the data preprocessing. About the decision tree regression, it's easy to overfit, especially when the amount of the data is small, interpolating controls complexity. Performance for features with a wide range of the value can lead to over-dependence.